Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 2095. It's a delete the middle node of a linked list. Basically, you have given a linked list, right? And as you can see here, 7 is the middle of this linked list, means 3 in the left and 3 in the right. And this is 7 in the middle, right? So this 7 you have to delete. Okay, and whatever the data remain here, right, means the remaining nodes from this given head you have to return, okay, after deleting. So how will you approach this problem? Okay, the very first thing, you have to find the first what is our middle in the given linked list, right? And once you will find the this is our middle, right, you need to replace, right? How will you replace this? Let's talk about this. Okay, so let's suppose that how we are going to approach to find the middle, right? So what we should do is, let's suppose we'll start the pointer from here, and this pointer will keep moving till the last. So this pointer is called the fast pointer. We'll take two pointer, fast pointer and slow pointer, both from the same head, you can say, the very first node. Okay, that is called the head. This is nothing but our given head. Okay, as you can see here. Okay, so both we can start from here. And how, what we will do, that the fast will go, it will jump to the not the next, but it will go to the here directly, means one, it will skip one and it will go to the next. Okay, but slow will come slowly. Okay, so slow will come here, let's suppose here, and fast will come here. Okay, next time what will happen, the fast will move at this position, right, but slow will remain at here, right? Slow again, the next time what will happen, the fast will reach to the last position, correct, because we are skipping the one point, right, one node. And the slow will come here at the middle. So now you can see that our slow is at the middle and fast is at the last. So when we check that what is the next is the null, right? So when the fast dot next is null or fast is at null, right, at that point we will see that our slow is at the middle, right? It is a concept based on two pointer concept, where we have two pointer, fast and slow pointer. So what happens, that there is a concept that if two person are running on a single line, right, so if one is running faster than the another one, so one will reach to the end, then the another will reach at the middle, right? Like that we can think. Okay, so what will happen, that once you will find the middle, right, you need to delete the value, right, with, we have, let's suppose 4 we have, 7 we have, and 1 we have, correct? These three nodes we have given, let's suppose, and it is connected like that. Okay, now if I want to delete, it means this pointer that is pointing to the 7, it should not point to here, but it should point to directly to this. It means this part will automatically will get deleted. Okay, this is what we want. So we have to remove this pointer, and these pointers should directly move to this pointer. This is we want, right? Let's talk about again. So in linked list, these points is very important, because this is the linking point, right? So similarly, this is also linking point, right guys? So if I will remove this point, the relationship between the 7 and 1 is gone. And if this point is not going to point out at 7, but this point is going to directly point to the 1, it means this relation is no more existing. Okay, so this is what we will do. So how will you do that? This is very important. Okay, let's talk about more. So let's suppose we have 4, 7 and 1, correct? So what we will do, that these 3 nodes we have in the given list, we are talking about this part only. Okay, so we'll take, let's say there is a previous, and previous node will put here, and this is, we know that this is our slow, and let's suppose the fast is somewhere else. Okay, so let's talk about not here but somewhere else it have, right? So if I want to remove this pointer with this, right? So what we need to do is we just say, okay, when we reach here, previous will reach here, slow will reach here, right? So what we will do, we will say that the previous dot next means this, next means we are talking about this one, it should go to this. And what is this? This is the slow dot next. So we just need to do is the slow dot next. Are you understanding? So this relation will get affected. I think you will understand. Okay, don't think about this thing, just think that we have two nodes. We have the very first node is called the previous, we will mark, and another will mark as a slow. Okay, so if I want to break this relation from here to here, that is pointing, right? What we need to do, this is at previous, so previous dot next means this should point to this. And what is this? The slow dot next. If 7 is at slow is at 7, slow dot next means 1, right? So now the point will happen like this is the 4, and 4 means previous dot next is nothing but the slow dot next. Automatically 7 will get removed, and this is exactly we are going to do, guys. Okay, I hope you understand. So let's understand here. So sorry, if you see the code, right, the very first what we need to do is we'll check the head should not be null. If head is null, we don't need to do further. Go ahead and check the rest of the node, because it's already null, means there is no data in the head. Okay, no more node is there, so we'll return the null here. This is the very best case that you should apply, otherwise the test cases will fail. Then we'll take slow, fast, and previous. Slow and fast will start from the very first node is head, and previous will take point to the null. It will not have any data. Okay, so from where we'll get the data? Let's see. So we need to check the while loop. We'll start when the fast is null or fast dot next is null, means we are at the last node. Okay, then we first mark the previous is a slow. So whenever we start from the very first node, right, the very first node, where is the slow? Slow is at the head, right, the very first node. So we'll say, okay, let's keep the node as a previous. So you will keep the previous as a slow. Then you will move your slow to slow dot next. So it will keep moving ahead, and then we'll go to the fast. The fast will move to 2 point, right? One we have to skip, and we have to go to the next, right? So we know that this is the concept we wanted, but we have to also store one more value, that is this case, right? If you have used the another problem, find middle, right, at that point we don't use to use the previous, we only need the fast and slow, right? So we will do that, but extra we have to use is a previous, right, like this. So previous will always having the slow, means the previous slow, you can say that. Okay, previous slow. So previous slow dot next, we can say, is nothing but the slow dot next that we were talking about, right? So we will mark this, and then what will happen, that previous and slow will get affected, means previous dot next relation means previous slow to the slow dot next, it become, and it will remove the 7 from there. Okay, let me try run. Okay, so what will happen, guys, the very first, let's suppose we have the node, we have 1 2 3, then let's suppose we have 4 5 and 6. Okay, and one more we should take. Let's suppose remove one last from here. Okay, what is the middle? Middle is the 3, correct? And where is the slow? Slow is at this position. Okay, so let's go with the very first one, right, not from here. So what we want is, we need 3 things: slow, fast, and previous. So what we want is, we want to start from slow here, right? Fast is also from here, but slow will take as a previous, as a null. So we have taken the previous, right? But previous is not pointing here. Okay, so when the slow will move ahead means if I remove the slow from here, where the slow will go, the next point will do slow here. Where the fast will go, guys, fast will remove from here, and where it will go, at here, fast. At that time, before it moving from here to here, right, we will mark this as a previous. To who? We will point this value to here. Okay, at that point, and then we move to this point. This is what we want. Okay, before moving to here. So exactly after the first call, when this while loop go, it will look like this. So because we have marked the previous to the slow, means slow was at here, and slow we have moved to the next point, right, and fast we have moved to the next, right, like that. Let's go to the next point. Okay, so when the slow will move from here to here, right, what will happen, guys, is we will remove from here, correct? I'm not talking about the previous here because we know that previous will first we have to do. Okay, so now previous will come here. So we have to remove the previous from here, right? And now the previous will come to at this sorry, from here to here. This is your previous. Okay, and it will come here at a slow will come here, correct? Where will the fast will go? Fast will remove from here, and it will go to the last point. So you start from the that node, right? Here is the fast. Okay, now the scene comes what we need to do. Let's try to understand here, guys. Okay, so we have to break this relation the very first, and we have to mark this as a this point to this point. So if we know that this is previous and we have to break this relation, right? So we'll say, okay, previous, we have written already, don't worry. Okay, so we have done that the previous dot next. So once you know that the slow will reach, right, so this condition already matches that fast dot next and fast both are saying that this is the null value, right? So once null means our middle element we found at the slow. So this is your middle, right? Once you find the middle means you cannot go further in this loop. This while loop will break. Okay, so now you know that your middle, right? So what you need to do, you have to say, okay, this we have to build and this we have to break, right? How will break the relation? Just use the previous dot next means this should not point here, but this should point to this 4, right? Not the 3, not to the 3, but the 4. So you will do slow dot next. Where is the slow? Slow is at here. So you will do slow dot next means 4. You will get the slow dot 4, and just you return the head means it will get removed and it will become like what? 1, 2, 4, and 5, and this will get replaced, right? And you will get this value. So this is your head. Head will point to here always. It was here. Head was also here. Okay, because head contains all the data. I hope you will like this video. Obviously, it's little tricky, and tricky is that very first you need to find the middle, and if you already knows that to find the middle, right, we need the fast and slow pointer, and once your fast will reach to the null or next to null, it means that you have the slow at middle, right? You will find the slow. Once once this condition matches, you know that slow, where is the slow. Once you know that slow is at middle, right, you just need to come out of the while loop because this loop will not go further. It will not work again. So control will come from out, and once the control will come from the out, at this position you have to maintain the relation previous dot next equal to slow dot next, and you will remove the middle element, and finally will return the head. This is what we have, guys. Thank you so much for watching till now. If you have any doubt, let me know in the comment section. Thank you so much.